Hello class, this is Dr. Andrasek, and I want to welcome you to our final lecture in this series on research methods. This lecture is titled Types of Research Designs. We've talked about a lot of parts of a research project, starting in the very beginning with an idea that you might have, and going all the way in to the end on how you would use methods in order to draw conclusions or describe or explain or predict. And in between, we talked about articulating your problem, your purpose, your objectives. Will you have a hypothesis? Not necessary if you're doing qualitative research. We talked about methods. Techniques such as sampling and collecting your data, measuring your data. All of these pieces, like a puzzle, have to combine into the big picture, which is the research design. So in this final lecture, you will be introduced to 5 descriptive designs used to develop research studies. The examples will center upon those designs most commonly used in studies in the field of library and information science, because that's where you're headed. A reminder, this lecture builds upon the previous lectures on data management and the lectures I did on procedures related to naming variables and drawing your sampling. So you may want to review your notes on those topics before you view this final lecture. And if you skipped over those lectures, it will be very difficult for you to follow along with this one. Now, your author of your textbook, Newman, collects a bunch of designs together from research methodology, and he called these descriptive designs. Other textbooks might use other vocabulary to describe this, but I'm going with the way that Newman categorizes things. And Newman says that descriptive designs are used when you have basic information and are ready to describe it in greater depth. All research designs are based on finding answers to questions, but descriptive research defines those questions in terms of variables. These are the 5 designs that Newman categorizes as descriptive designs. Again, there are authors of other textbooks on research methods that might have a slightly different take on this. He starts with the simplest kind of design, which is a case study. He then describes survey research. I put transaction log analysis on this list because it's used in library and information science. He discusses it in a roundabout way. And then he talks about existing statistics. When I took research methods, we referred to that as extant data. And finally, there's the big kahuna of them all, and that's experimental research. Let's start with a case study by defining it. Newman says a case study research examines one or a handful of cases over a duration of time with detailed, varied, and extensive data, usually qualitative data. And a case study can center upon a single person. It can center upon a single library. It could center upon a library's web page. It's a single entity that you're studying in great depth, and you choose that entity because you feel that it's representative of that area of your research in which you're seeking answers. So here's an example of a case study. A researcher wants to find out whether library anxiety decreases with repeated use of the library. She identifies a college student, one student, who reports great anxiety when assigned to do research using the library. So she makes an arrangement with this student. Of course, she gets informed consent and goes through all of the necessary procedures. But she wants to have a student who is willing to keep using the library. Most college students have to keep using the library. So the student reports that he is using the library regularly, and the researcher interviews the student monthly over a one-semester period. She asks the student to describe his feelings of anxiety and records all his responses. So in a qualitative case study such as this, with a single participant, what would the reporting look like? There are many, many ways you can do this. Here's an example of how the researcher might be keeping track of her meetings with the student. And of course, you probably have a journal or a log of some sort where she is tape recording what he has to say and then making her own notes in her log. But it boils down to this, especially if you're going to report it in a summarized form in an article that you write. You might show something like this. What happened at the first meeting, the second meeting, the third meeting, and the last meeting. And you might want to break it down into subcategories that you learn from the participant causes anxiety. Consulting with the librarian, it was high when the person started, became lesser. Finding e-resources on his own, high in the beginning, became lesser. Evaluating his resources, that anxiety level remained high throughout. We've talked about survey research in terms of writing survey items and a few other aspects of surveys. I like this definition of a survey. It's the broad area of survey research. It involves asking questions of respondents. Newman says, survey research follows the principles of positivism, that researchers can precisely measure features of social reality and convert it into quantitative data. So Newman is looking at survey research from a purely quantitative perspective. However, there's survey research out there that's done on a qualitative level. So here's an example of a survey study. Say a librarian wants to find out what electronic resources students, faculty, administrators, and staff in a university are using. He creates a survey with these categorical variables as the basis: e-books, journal articles, educational reports, videos, art reproductions, musical scores, and other documents. He's got his variables, and the next step in developing a survey study is to write survey items, and you need to make sure that you have at least one survey item to cover each one of those variables. If you can think of 2 survey items or 3 survey items for each variable, you're better off. And this is how the researcher might report his findings, and this should look familiar to you. It's a contingency table. His variables for the respondents who he surveyed are running horizontally across the top of that contingency table, and his variables on the electronic resources that he was interested in investigating are running down the side. And of course, he would have data filled into those cells. So here's another example of a survey study that I thought was kind of interesting, and it has an international flavor to it. This is an actual study done by 2 investigators who wanted to find out the influence of agricultural research libraries in Nigeria. And they administered the Nigerian Agricultural Research Library Effectiveness Questionnaire. This is a real thing. To 340 researchers from all 14 agricultural institutes in Nigeria. They had a big N there, big number. Now, one of the things that they did for their reporting and for their data management and analysis was to look at correlations from that survey study. And here's how they reported their correlations between productivity and the use of the library by the researchers. Now, have a look at that table. And as I said, you need to hearken back to the lecture on data management where we talked about reporting correlations from a study. And you might be looking at this and saying, what? That does not look like the correlation matrix that we saw in the previous lecture. So let's talk about this table a bit. What the reporting data in your research articles in many cases is done according to a style that the authors of the article prefer. And most journals will give the authors of the article pretty much latitude in how they want to report their findings and their tables of data. So here's what these two researchers did. They had running down the left-hand side the 14 agricultural institutes, and they gave them all acronyms. So running down the left-hand side, you see that. There are their correlation coefficients in the column right next to it. Their N, or their sample number, is in the third column, and there's their p-value in the fourth column. And they set their p-value at p is greater than 0.05, not significant, p-value less than 0.05, significant. So how do you interpret this? Well, they were looking for correlation, a relationship between productivity of faculty in these agricultural institutes and the use of the library. So the question is, do people who use the library more produce more research? And first thing that I did was to look for a positive correlation, and here you can see 21 faculty in NIHORT Institute responded. If you get out your correlation value chart, and you'll see that that 0.359 is hovering right around a 0.30, and that's a weak correlation. And if you look at the p-value on the right, 0.110 is way up above 0.05, so it's a weak correlation. It did not reach significance. What's that telling us? It's telling us there was no relationship between productivity of the faculty and the use of their library in that particular agricultural institute. Let's see if we can find a stronger correlation. And here's one, negative 0.814. Did it achieve significance? Yes. Look on the right-hand column. 0.002 is way below the 0.05 cutoff for significance. So what we have here is a negative correlation. Notice there were only 11 respondents to the survey in that particular institute, so that small sample size isn't good. And what does that negative 0.814 mean? Well, it means that it means that the faculty members who were showing high productivity in that institute weren't necessarily using the library a great deal. And it's, they achieved significance there, so there's some kind of relationship going on, we think. Here's yet another format I found in an article for reporting correlations. And to me, this is very confusing, but let's have a look at it because there's some very interesting things going on here. Johnson did a study on correlations between library users and indicators of community-level social capital. She looked at things such as trust, community involvement, and civic engagement. Those were her questions centered upon those topics in her survey. Now this looks to me at first glance like a contingency table because you have 3 variables running across the top: library visits, education, and income, and then 3 groups of variables running down the left-hand side: trust, community involvement, and civic engagement. So it almost looks like it's a contingency table. But we know it's not because she clearly labeled it as Table 8, correlations between library users and indicators of community-level social capital. And here's a researcher who prefers the term indicators to the term variables. These were her variables, but she sticks with calling them indicators throughout the article. Now let's look at at least one set of correlations here. She looked at whether library visits were correlated or related to how much people use a library trust people. She got a 0.081 correlation. Again, if you get out your correlation values, those values that hover between 0.0 and 0.1, it's almost no correlation whatsoever. So the amount of library visits wasn't really related to people's amount of trust in other people. She looked at education. Did your level of education affect trusting other people? And she got a 0.28, and she got the same for same value, 0.28. Under income, again, if you look at your values, this is going to tell you something about the strengths of these relationships. Let's move on to transaction log analysis. This is a method that captures data from a computer or computerized system so that it can be exported and analyzed. Transaction log analysis has an interesting history. It was first developed as a means of evaluating the performance of online public access catalogs, or OPACs. Lots and lots of transaction log analysis studies back in the 1970s, 1980s, when OPACs were very new. Today, transaction log analysis is increasingly used to study how people use and search websites. In recent years, user log analysis has been employed as a digital library evaluation tool. I'm going to use a pretty boring example for transaction log analysis. Let's say we have a systems manager who wants to measure the usage of electronic journals originating from the university's electronic journal subscriptions. She uses the transaction report sent to her by the providers of electronic journals using these standard, what are called counter categories. And here are the counter categories: number of successful full-text article requests by month and journal, number of successful gold open access full-text article requests by month and journal, access denied to full-text article requests by month, journal, and category, and number of successful full-text article requests by year of publication and journal. I chose just one of those, the first one, number of successful full-text article requests by month and journal. Now, these counter categories are simply standards. You rely on the providers of your electronic journals to comply with those standards and to send you reports that you can work with. This doesn't always happen, so a lot of systems librarians find themselves still having to create some of their own reports. Well, if you did a study on this, you would end up with a table that looks something like this. And again, it's a contingency table. You'd have all the titles of all the journals you're getting from that particular provider, and there might be 2,000 of them, there might be 20 of them. Those would run down the left-hand side, and your months would run across the top. And you would fill your data into that table. somewhat similar to transaction log analysis because it has some overlap of data you can use, is this category that your textbook author calls existing statistics. It's a method that uses statistics or data sets that are readily accessible to the public. Many times these are free, sometimes you can download them from the internet. And I gave two examples here of major causes of mortality. In these mortality statistics, you can go on the internet and download a bunch of them from places like the National Institutes of Health or the Centers for Disease Control and Prevention. You can download a ton of stuff from the Census Bureau, and these are used routinely by researchers, and they come in handy for librarians at times too, especially if you're doing community profiles. Or you can rely on statistics that you already have on hand, that you've logged in your own library, and this is where existing statistics overlaps with transaction analysis, because those existing statistics might be the result of transactions. So here's an example of existing statistics that you could use in a real library situation if this occasion arose. A systems manager must provide evidence that the new and expensive interface for the catalog is yielding a return on investment. So she could do a transaction analysis and look at the usage, but instead she decides she wants some richer data. She compares the database entries kept by the help desk staff on the number of and duration of catalog assistance requests before the new interface was installed to those same types of requests after the new interface was installed. And then all she has to do is look at the numbers. This could be a simple frequency count, and she wants to see if the frequencies are really, for the assistance requests, have really gone down. So in this hypothetical example, the good news is the numbers are way down. The bad news is she is asked to reduce the number of help desk staff. And this happens in real life. And now we get to this final part of the lecture that covers experimental research designs. I like this definition: research in which the researcher manipulates one or more variables and controls and measures any change in other variables. Now, there are several types of experimental designs. The most rigorous one is the true experiment, also called the classical experiment. I'm going to give you some examples from these types of experimental designs, and you'll notice that I kept the classic or true experiment for last. We'll first look at pre-experimental designs, and there are several in your textbook. I believe Newman lists 3 designs that he categorizes as pre-experimental. I could only find examples of 2. So I'm only going to cover the one group pretest, post-test, and the one-shot case study with no pretest. Quasi-experiments abound, and you'll see why once we get to that example. And then the classic or true experiment. What makes it a true experiment? Well, let's find out. Let's start with some samples of common pre-experimental designs. Here's my first sample study. This is taken from a real study, the effect of training on searching, and by that we mean online searching. So in this example, I say a librarian who teaches database searching wants to investigate whether training on a database improves searching results and whether it increases satisfaction with those results. She asked students who received training on LexisNexis 2, and this was all anonymous. They had to give informed consent, but their names were all stripped out of every piece of paper that they filled out. So after that training on LexisNexis, she asks them to, 1, take a search skills test showing how they will construct their searches. And she scored those. 2, rate their satisfaction with search results on a scale of 1 low to 5 high. 3, she asked them to report both their gender and their native language on those tests that they took. At the end of the testing period, she scored the search skills test based on effective searching techniques, and she scored their satisfaction sheets using that Likert scale of 1 to 5. There were actually 2 librarians who sort of made their claim to fame on this study, and their names were Diane DiMartino and Lucinda Zoe. So I've credited them with this. I'm basing this on what they really did. So let's harken back to what we talked about in terms of independent variables and dependent variables. They've got a bunch of things going on in this study. First, they have training. The students had to receive the training. And then they had to take a satisfaction rating test, and then the librarians actually scored their searching techniques at the end. So in all of this stuff going on, what is the independent variable and what are the 2 dependent variables? Think about that just a moment. And here are the answers. The independent variable is the database training. That's what they call your treatment. That's what the librarians made happen. They gave the training, and they hoped it would make a difference. Now, they had 2 dependent variables. The first one was the scores on their searching skills tests, and the second one were the ratings that the students gave them on their satisfaction with results. And in addition to that, they had 2 more categorical variables, gender and native language. Now here are the 2 pre-experimental designs that pop up every now and then in library and information science studies. One is what they call the one-group pre-test, post-test design. You have a single group. You test that group before and after they receive your treatment, before and after they get that independent variable. Then you have the one-shot case study. No pretest, none whatsoever. You have a single group of subjects who receive the treatment and results are measured. So you can have more than one dependent variable in either one of these types. But the question is, what were DiMartino and Zoe doing with their database training as their IV, their scores as their DV, and their ratings as their DV? You know, which one of these pre-experimental designs best describes that particular study? Just think about it a minute. Well, they did not test before and after their treatment. What they did do was had no pretest. They had a single group of subjects who received the treatment, and then they measured their results using those 2 dependent variables. So theirs is clearly a one-shot case study. And they reported the results of their study on a bunch of contingency tables. This is one that I copied from their article, and I sort of modified it to clean it up a little bit. They reported a whole lot of stuff in this table, including percentages as well as the numbers. So to simplify things, here is one thing that they looked at. They looked at native language, which was their categorical variable. Was the person a native speaker, East Asian, or European? Those were their 3 categories. And then they looked at satisfaction, whether they were satisfied with results or not satisfied with results. Their research question was, does whether or not you're a native speaker have any kind of relationship to whether you're satisfied with a result or not. And these were their raw numbers. And this is actually their chi-squared test. You can see the statistical notations below the table. And there's their p-value, which came out as p equals 0.004, which is way below 0.05. So this is a chi-square test, and they're seeing some kind of relationship there. That whether or not you're a native speaker actually does have something to do with how satisfied those students were with their searching results. Here's my second sample, attitudes towards reading. You saw this study or something like it in the data management lecture series. I've refined it a little bit here because I wanted to talk about a few things. So here we have a librarian who hypothesizes that children's attitudes towards reading might differ depending upon restrictions placed on their book selections. She compares the attitudes towards reading in 30 fifth graders restricted to signing out accelerated reader books during the school year to those same fifth graders' attitudes towards reading immediately following the close of the summer reading program, which placed no restrictions on book selections. So here are her variables. She's got an independent variable, constraints on reading. This is what she's controlling by selecting students and testing them before summer reading and then after summer reading. So that she tested them before that where they were used to having constraints on the reading, and at the end of summer where they got used to not having constraints on their reading. She wanted to see if there was a difference in their attitude, and to do that her dependent variable that she used were scores on a reading attitude scale. And I think you saw this before in the other lecture on inferential statistics. But I'm giving you a slightly different scenario here. She's using just one group of students, 30 students, same 30 students. She issues the elementary reading attitude survey before the summer reading program. This is a much simpler design. She doesn't have to deal with the schools. She can issue this before they start their summer reading program, and she can make it sort of a fun thing. And then she issues the same scale after the summer reading program. Now she's got a pre-experimental design here. Which one is it? Is it the one group pre-test, post-test design where a single group is tested before and after receiving the treatment? Or is it the one-shot case study as we saw before with no pre-test? Well, you can probably take a pretty quick stab at this. Hers is the one group pre-test, post-test design because she gave them that attitude test before and after. This is sometimes called test and retest. Now, with these 30 students, and I made this up, but let's look at these hypothetical statistics. The librarian computes the mean scores for each group. She's got a group with she computes the mean scores before and after, I should say there. She's got the group that before they had constraints and after they had no constraints. So she's got two sets of scores. The mean scores are 14 points apart. Now, is that a big enough spread in order for her to say that not having constraints on their reading selections made a difference? Well, you look at her p-value to find out. She ran a t-test on those 30 tests before and after, and her p was less than 0.05, so it looks like she's onto something. Now, when you saw this hypothetical study in the earlier lecture, I made up an entirely different set of numbers. That librarian had 222 fifth graders participate. Usually larger samples will help with significance, but look at these compare these two p-values. The librarian who had the 30 students, one group who she tested before and after the summer reading program, she achieved significance. The other study that had 222 students in it, where there were two groups, one had the constraints and the other one had no constraints, that did not achieve significance. Why? Well, there could be a lot of reasons for it, but one of the things that I want you to take note of here is that on the left, that small one group sample with only 30 students had that 14-point difference in its means, whereas the large two group sample only had a 7-point difference in its mean. So a larger difference in means tends to contribute to significance. You're seeing more of a difference in that smaller group. Now, there are some questions of validity also when you use a one-group pre-test, post-test research design. You know, what's the big deal about having two groups? Well, if you can have a control group and that doesn't get your treatment, and you can have an experimental group that does get your treatment, and the two groups are kept separate and they're not allowed to talk to each other or anything, you've got two sets of pretty clean data there to work with. When you take a group of children, fifth graders are pretty chatty, and they form friendships either before they join the summer reading program or during the summer reading program, and they might talk to each other about that test. They might talk to their parents about the test. You know, parents saying, what is that test? You know, parents might say to you as the researcher, well, I'll let my child do this study with you if you show me the test first. Well, if you do that, then you've got a bunch of parents who may say things to their kids about what they think they should be putting down as responses. And the children might want to please the librarian as well. So you have that Hawthorne effect that we talked about when we talked about validity, where you have people participating in a study who want to do well, who want to please the researcher, who feel special because they've been selected to do something. And this could have an effect on that test-retest. This could be, as the students finish the summer and they've had a good time, they may decide to put really positive answers down, and that may account for that large 14-point difference in means. This is a limitation. This is what they call a limitation of a study, and it ought to be discussed when you report your findings in a research article. And now we have samples of experimental designs. We have pre-experimental, now we're going to what's more experimental. This is a sample study called Does Signage Make a Difference? A librarian who manages a computer lab wants to know whether it is more effective to place signs on how to print documents at each computer or at the printer located in the middle of the lab. She thinks that placing a sign at each computer is a better method than placing one sign at the central printer. She decides to test her hypothesis by measuring the number of requests for assistance when signs are at the computers versus the number of requests for assistance when a sign is placed by placed by the central printer. Excuse me. So she's got an independent variable and she's got a dependent variable. What are they? And she's got two groups. She's got a pretty complicated design going here. Group 1 uses the sign position at their computers, and she counts the help requests. Group 2 has to go to the printer and read the sign, and then she counts the help requests. So what's the treatment and what are the measures? The independent variable is the treatment, that's the placement of signs. The dependent variable measures whether or not there's a difference made by sign placement. by counting the number of requests for assistance. And here's what her data collection shows. And there are many ways you could collect this data, but I had a student who actually proposed this, and her proposal was to count the number of students and the number of assistance requests by the hour. And so the data collection spreadsheet might look something like this. Note that for Group 1, signs at the computer and in Lab A, and Group 2, signs at the printer in Lab B, she has exactly the same number of students, 290 each. And then the number of assistance requests where the signs were at the computer were 102 during those 5 hours, whereas in the same 5-hour period, the requests for assistance in the lab where the sign is at the printer, there were 142. So a lot more. Here's how you would here's how you could report your data in your research article. And my N number there is incorrect, I'm sorry. Her N was N equals 580. So that N under that table should be N equals 580. And P is less than 0.05. In this hypothetical research situation, the scoring results show a significance level of less than 0.05. The librarian can say that the signs at the computers were more effective than placing the signs at the printers. Now, what kind of design is this? Well, I've listed the 3 here from Newman's book that are pretty typical as not quite up there with the classic experiment. So here's the diagram again of this printer computer sign, and it's not a one-group pretest post-test. You're not going to pretest and post-test people using a computer lab. It's not a one-shot group study. It's what they call a quasi-experiment. And what does that mean? Well, it has a lot of the elements that a true experiment would have, but it has no control group. It has no random selection. Whoever happened to walk into those computer labs, they took the first 290 in each lab, and that's it. There was no random selection going on. So you're losing control of the conditions that you want to try and get the same when you're doing an experiment with 2 groups. You're losing control in a quasi-experiment. The quasi-experiments come in very handy when you want to conduct an experiment in a real situation rather than in a lab. And now we get to the classic or true experimental design. This is right from your textbook, and I think you see this in most textbooks on research methods. A true experiment must have an independent variable. It must have at least one dependent variable. It has to be a way to measure whether or not your independent variable made a difference. It has a pretest. It has a post-test. You want to find out what the situation was like before you do your treatment, and you want to find out afterwards whether your treatment made a difference. You have to have experimental groups. You can have 1, you can have 2, you can have 3. Most people have a control group that doesn't get the treatment and an experimental group that does get the treatment. And you have to have random assignment. Let's talk a little bit more about those. Here's the diagram. This is just another way of looking at it to help you understand. When you're doing an experiment with 2 groups, your control group gets the pretest, it does not get the treatment, and it gets the post-test. Your experimental group gets the same pretest, gets the treatment, and gets the same post-test. So, again, you have to have a control group and at least one experimental group. Members of both groups are randomly selected and assigned. Students in both groups are pre-tested. The experimental group receives the treatment. The control group does not receive the treatment, and results for both groups are measured using at least one dependent variable. Here's an example of a study that I based loosely on a study that was actually done many, many, many years ago. The people in University of Illinois got a big grant, and they did a study something similar to this. They wanted to know, does instruction on the online catalog make a difference when you're with people who are then trying to locate their materials in the library? So basically they did this. Librarians had spent many hours on library instruction for first-year college students, and they wanted to know whether their classes that teach students how to find materials using the library's online catalog make a difference in those students' abilities to actually locate the materials on the shelves. You know, after all this instruction, can they do it by themselves is what they were interested in finding out. Now, they selected a whole bunch of students. I'm going to use the number 60 here. So say those librarians selected 60 students at random from the records of incoming students. They got permission from the registrar to actually pull at random 60 names. They then randomly assigned those 60 students to 30 students in one group who would receive online catalog instruction, and 30 students in the other group who will receive instruction after the experiment ends. It wouldn't be fair to those students to not give them instruction at all. There are ethical issues involved in that. But it's okay if to take 30 students, give them the instruction first, and then 30 more students who agree to be in your study, and you tell them, you get the instruction a little later. You might give them a handout or something like that. So you have your 60 students, you have your control group who is not getting the instruction, not at this time, and the other 30 students who did get the instruction. The librarians in that famous study actually shadowed the students. They followed them and watched what they did as they searched for materials. Now, they had informed consent from the students. They understood they were going to be followed around, and that was part of participating in this study. The librarians recorded each student's success in finding those materials. So here's the diagram once again for a true experiment. Has to have a control group, has to have an experimental group. All right, they had that, 2 groups proposed. Members of both groups were randomly selected and assigned. They did that. The experimental group received the online catalog instruction. That was their IV, their independent variable. The control group did not receive that IV. And both groups were charted and measured for success in finding their material. So what's missing from this research design that that denies it from being categorized as a true experiment? Well, if you said the pretest, that's absolutely correct. Because they did not do a pretest, we once again have what is called a quasi-experiment. It almost does it. It meets a lot of the requirements of a true experiment, but not every single one. Now, Newman refers to this as a 2-group post-test only design. It's the same thing. It falls under that quasi-experimental research design category. How would they do data collection? Well, I don't know exactly how those people in the University of Illinois did their data collection, so I sort of made this up. If I were doing this sort of a research experiment, I think that I would want to break it down into some subcategories. If I were shadowing these students after they received instruction, I'd want to know, first of all, could they do the catalog search? Second, did they make an item list? Did they write stuff down? Third, did they record call numbers? Students often forget to do that. 4, could they find the shelves? And 5, could they find the items? And it could be reported in a number of ways, but you know, what I'd like to see if I were reading this study is how the control group did in each one of those subcategories and how the experimental group did. And I'd also be very interested in knowing which ones needed help. They could do it, but they needed help, and which ones could do it independently. And so you could report something like this. And again, you're computing scores here. You would record a 1 if a student needed help, record a 2 if a student did this independently, and then you add up those scores. And the people who did it independently, the group that had the people that had showed the most independence are going to have the higher score because you recorded a 2 there. Because you only gave a 1 if they needed help, you're going to have the lower scores. So it's all about computing some numbers here. And what would you do in the end for that type of study? You could do a t-test. And there's a number of ways that you could run data on that. And now we get to the bitter end here, and I wanted to say a few words about naming your research design, because I want you to give your research design a name in your research proposal that you're going to hand in at the end of this semester. And there are many different ways that you can name your research design. I'm going to give you some tips here, and I'll give you some more feedback once I look at your research methods sheets and I get your drafts. So Newman categorizes research designs by purpose. I think this is a nice way to think about it. If you look at that chart in your textbook on page 16, I think I've pointed it out to you more than once. I really like it. On page 16, he categorizes research designs as being exploratory, descriptive, or explanatory. Now, I'm going to go a step further here. Exploratory designs are almost always aligned with qualitative research. I mean, somebody called a study a qualitative exploratory study. That says it all. It makes it very, very clear what their study is. So that's one way of describing your study, if it is a qualitative exploratory study. Now, on the other hand, if you start to describe things in some detail, then your research design might fall into these other categories. You can have qualitative descriptive studies. You can have quantitative descriptive studies. And you can have quantitative explanatory studies. How does that tie to what we talked about today? Well, here's how it ties to the examples that I drew from the literature and from my imagination for you. One of the things you can ask yourself is, does my research describe or explain? And a qualitative descriptive research design are generally things like a case study. You're describing, but in a very, very qualitative way. You're not counting numbers. That librarian who followed the progress of that one student and whether or not his anxiety was reduced over the course of a semester, she wasn't counting things really. She was writing a narrative and tracking his progress. Survey research can be a qualitative descriptive design if you're using mostly or all open-ended questions. And sometimes you'll see in a research study, the report in the article says the researcher used an open-ended questionnaire. That's telling you something. That's telling you that this is probably a qualitative descriptive research design. Now we get to quantitative descriptive. Survey research design that's quantitative descriptive is mostly forced answer questions. That doesn't mean that you absolutely cannot put an open-ended question in there, but it's mostly forced answer questions. Multiple choice, fill in the blank, do the checklist. rate these. These are all forced answers. Transaction log analysis is quantitative most of the time. I can't think of an instance where I've read an article where transaction log analysis was quantitative. Well, I take that back. Web usability studies quite often use transaction log analysis, and web usability studies might have, 5 or 7 people testing your web design, and so that would be a qualitative descriptive. And then you have existing statistics. Whenever you're doing statistics, you're into quantitative design. And finally, we get to the big one, the experimental research. This is where your quantitative design becomes explanatory. Sometimes you'll see this referred to as cause-effect research. You can't really make claims about your independent variable making a significant difference between one group and another group unless you've got some kind of experimental design. You simply can't make those claims. Now, can you survey people during the course of an experiment? Sure you can. So some of these things can be mixed and matched, but I wanted to break it down for you in this way because it follows what your textbook explains and the way it explains it. And it aligns pretty well with the type of research designs that you will see in library and information science studies. And so, my parting words to you are, strive for a coherent research plan. All of these pieces that we've been talking about and that you've been working on and pondering, they have to come together in the end into a coherent research plan. You want, if you're going to do a mostly forced answer survey, and you're going to do a frequency count, you're going to add things up, and your proposal is to, see how people feel about these different variables in your survey, and you're doing counts, then that's quantitative. It's probably a quantitative descriptive design. If, on the other hand, you're simply going to explore, what's going on in one particular library and interview people and take observations, and your proposal is to write a rich narrative of what you find. Use content analysis. Note I did not put content analysis in this because it's not a design. It's a data analysis method, data collection, data analysis method. And it can be associated with either qualitative or quantitative. But in the end, you have to make the decision of how you're going to name your research design based upon these pieces. And here are my references. And I would like to acknowledge 2 of my former students, Bonnie Parker and Andrew Schwartz, whose ideas formed the basis for the 2 examples that I gave you in this presentation, the computer science study and the attitudes on reading comparison sample. I want to thank you for your attention and your attendance. And that brings this series of lectures to a close.